Hello everyone, the purpose of this video is to take you through an in-class demo for this week relating to some activities illustrating change detection. And change detection is really pretty neat because it enables us to do to compare past to present or even the predictability into the future. And so I want to take you through a couple of in-class exercises along with some solutions that you can practice at home. And as example like this that you see on the screen, which is a great example of a final class project that's relatively simple and straightforward, but yet it's doable and super tangible, and that we only need a couple of data sets. So with that being said, our in-class activity that we would do this week typically involves finding areas, in this case, a stumps problem. So find areas that were once trees. So in 1875, that's the L75 Calc 7-G raster that you see right here. So in 1875, that were once trees and that are now water in present day, or thereabouts in 1989, Calc 7-G. So what we're going to do is write out the true areas to 1 and the false areas to 0. So find areas that were once trees, which this should be values of 4 for us, but we'll go double check that when we explore our data. And then that are now water, or values of 1 in present day. So let's go take a look at that and see what we can do in Pro. So in Pro, I've already actually demoed this out. So I'll be showing you some key things to be aware of along the way, as well as evaluating, exploring the solution guide for this too. So we're going to find the areas that were once trees about 100 years ago. Once trees, and this shows us that we have values of 4. Again, do not confuse the ID with the value, but values of 4 that are trees and that are now water in present day. Here we can see in present day values of 1 that are open water. So we're essentially looking for stump fields. Now the thing that I'd like to have you see on my screen, and make sure that it does not happen to you, that's why it's kind of a good reminder we do this. Make sure that when you see this teal color in here, it means that something is selected. And I had that up in my L75 Calc 7-G grid when I selected the trees. Make sure that you clear all selections before you start doing any processing, because anytime you have something selected, it's going to manifest itself through your analysis or your processing. So make sure everything is clear. All selections are clear. Now your colors might look differently, but the only 2 data sets you will need for this activity or this little exercise are the L75 Calc 7-G raster and the L89 Calc 7-G raster. Both of those data sets are located in the grid intro folder inside, or in the grid training folder that was used in week 1. And then from the grid training into the grid intro folder. So most of us are familiar with these data sets anyway, but in order to work through this exercise as you wish, you'll need those 2 data sets. Okay, so to begin, we want to find the areas that were once trees that are now water, and we know that we are looking for areas that are 4, and where those are true, and where those same areas are water in present day, that could indicate a stump field, for instance. So what I'm going to do is I'm going to open up the solution guide that is present for us, and let's go ahead and take a look at this solution guide to begin with, just so we could talk through it, and then I'll copy the syntax and drop it in our expression calculator for you. The word solution guide is there for you. Everything I'm demoing this week is provided there. I won't necessarily go through every single solution, but I encourage you to, because there are a lot of different ways that you can work through different scenarios. And I tried to give you a lot of them here just to show you the versatility that we find ourselves with in working with rasters, really, to be honest. So let's take a look at our Stumps demo, our kind of our little in-class activity. In that, we're finding areas that were once trees, values of 4, that were 1875 estimates, that are now water in present day. So they're water values of 1 in more recent years. We're going to write the true values to a 1 and a false value to a 0. So when we think about that, we've had the chance to work through our condition statements. We talked about the power of condition statements, but on the condition, where our L89 or our more current raster is tested and evaluated, that's our evaluator, test for equality, tested and evaluated for values of 1, which are water, and where L75 Calc 7-G is tested and evaluated for 4, so stump or trees in that case. So water and trees, where both of those share that same per cell overlay. Again, we're looking at direct overlay cells of common unit or common space when they're overlaying. Where both of those are true, let's write a 1. Where it's not, write a 0. So if you copy this out, or you can put it in by hand too, I encourage you to practice both. Inside of our, again, under our geoprocessing tools here, under your toolboxes, just as a reminder, we'll go down to math, algebra, and then raster calculator. And we see our 2 main grids that we need in here, our rasters, our L75 and our L89. And then our con statement, again, is located under our tool option here. So we can go through all this and type it in. I'm going to backspace this. And but ultimately, you're going to want to make sure that you go through this and type in here, for instance, the L75, and then we're going to look for our evaluator, which is our double equals up here. Tested and evaluated for 4, which are the trees. Kind of have to be a little bit careful here of our syntax as we're typing that in. And then we're going to say, under our tools, the ampersand, I always put in extra spaces in here. So we'll clear those out. And where L89 is tested and evaluated, our double equals for 1 in parentheses. So write a 1 and then a 0. I'm going to have to go back in here and clean this up again here. Okay, and I need a parenthesis at the beginning here. But essentially, when we have this all broken out, you'll see the same syntax right here. Well, in the order I put them in is a little bit different, but they're both the same, meaning the same thing. So if we go in there and we run this, we have our order of operations set. Always check your parentheses. Now here we have one that needs to close right up top up here, and that one does. And then we have another one that closes right here. And then we have a bigger one that closes the beginning and the end. So this will work for us. And let's go ahead and write that out. Now first, I need to make sure I'm in a suitable working directory here. I'm going to call this one Stumps. And I did this already. So we're going to see it look, it's going to not let us do that because I already have a raster called Stumps that we try, but essentially it's running this syntax here. So if we just clear that out, we'll drop in that syntax. So we have all of our values paired up, and if we were to run that, here's what we would have. We would have a Stumps raster that looks something, I'm going to move it up to the top up here. That looks like this. So in other words, all the areas that are red right here met our criteria of trees that from 100 years ago that are now water in present day or close to it. And all I did really, for the reason you do not see the ones in the 0 color, is I selected the symbology and I just masked that out to no color. So you're going to see that in a few of my examples. I just selected no color for that, just so that we can see the values of 1. So this is again kind of as just a binary way of yes, it met the criteria, or no, it did not, or areas or cells rather, cells that didn't meet the criteria, cells that did. This would happen just to show in red. Your colors might be different, but all of these should have values of 1. So explore our data, check our attributes. You should have 11,200 counts or cells of values of 1. If you did yours. So what this is telling us is if you were boating or traveling on here, these might be potential stump fields. Maybe, for all that. Let's take a look at a couple of other ways though that we can do this. What we did right here was a kind of a big initial lead-in condition statement that did sort of two tests for equality in one statement. Let's say we wanted to parse this out and multiply our rasters together or break them out. Break out, for instance, if we look at what we'll call old trees here, we'll create a new raster called old trees that is a condition in which L75, our older raster layer here, where those are tested and evaluated for trees, let's rate those out and let's call them a 1. So we're going to have old trees that have a value of 1 in that raster. Likewise, for the newer grid, or L89, or newer raster, we're going to create something that says now water. It's a new grid we're creating called now water on the condition where the L89 is tested and evaluated for water. Let's write them out the same value of 1, just as 1. So we're dealing with ones and zeros. So it's kind of true false. So let's go ahead and do that. Sometimes there's value in doing this so you know what's what. You're just breaking the data down a little bit more so that you can understand what you have to work with. There's value in that sometimes. So if we ran those condition statements, all we would do is I'd encourage you to write or type this out by hand if you can, so you get the practice of that. But for now, if I just took the condition statement and copied that, we're going to create something here. Close my symbology ramps here. We're going to clear our expressions by just clicking our erase button. So if we ran this condition statement right here, we would have something called, what was that? I think they're old stumps. And this should not let me, or what did I call that here before? Old trees is what I called it, old trees. So it's not going to like it because I just created that, but just again, pulling all the trees out, calling them 1, writing them to old trees. So if we ran that, I'm going to move this up and show you what that looks like. I'm just going to minimize my L89 and my L75. I'm going to move up my old trees now to show you what that looks like. There are my old trees. And I also ran the same extraction here, the same condition statement for the L89 or for the raster representing newer land use data to pull out water and call it 1. I ran that and called it now water. So let's pull that up so I can show you what that looks like. So what we're seeing now, if we zoom in on this, so our dark areas represent old trees, and our kind of our greenish area right here represents water. So, we could change that to a blue color if we wanted to make it more representative. But like I did with the stumps, all I did were the zeros. If you're seeing colors in your zeros, I just clicked on the 0 value in the symbology and just made that no color. That's all I did. You can set it back if you wanted to another color, but I just did that so we could easily see the true values of 1 for both of our old trees in dark and our new water in this green. But now if we zoom in on this, and I'm trying to find an area here. If we turn these on and off, you can see that there's a little bit of overlap in a few places. You can see it on the points here and kind of in some of these areas where you see the green, that'll overlap the dark color. Where those two cells are overlapping, that is what we are going to be using in our multiplication grid. Now we're going to multiply these two grids together, the now water and the old trees. So what we're dealing with, where the cells are right on top of each other like that, both of those have a value of 1. Those are the values we're interested in as potential stump fields, like we just did with that bigger condition statement earlier that sort of built all that whole nested statement together. It extracted out 4s and 1s and it called them a true value of 1. It's found those areas of overlap. Right now, we're just breaking the data down so you can see what's happening. You can see the overlap. Now we're going to multiply them together. In this case, it's sort of like doing a condition statement, but not really either. We're still preserving values of 1. So in your raster calculator, what you can do is just multiply your water, your now water, multiplied by your old trees. And what that's going to do is extract out all the areas of overlay where it's 1 times 1. It'll write those out to a value of 1. Where it's 1 times 0, that'll be 0. Or 0 and 0 will be just nothing as well. So I called mine Stumps 2, just from multiplying those together. And let's take a look at that. So again, I multiplied my now water with my old trees. Just going to minimize those. And move up Stumps 2 to the top. And again, I just set my 0 values to transparent. So there are my stumps. Now, we actually talked about it. There was a lot of overlap in here, and the purple areas right now for me are showing that. Those are my values, excuse me, of where 1 times 1 were 1. In other words, overlap of both of these two raster layers. So if I turn off everything but my original stumps layer, that's what we used in that big condition statement right up here that sort of did everything at once for us. But now that we multiplied those together, after we broke down the data sets right up here in old trees and now water, stumps should be the same as Stumps 2. So if we look at that Stumps 2, you see that there's direct overlap right there. So another way, that's a way to think about different ways to break data down using multiplying data. Another approach that you may want to think about as well is an example of the Stumps approach, but with a suitability approach. In other words, when we see adding rasters or we're adding them, it usually means suitability, because no longer are we going to get, if we have zeros in our raster for values, we're not going to end up, if we multiply them, it's not going to be a 0, like a true false, like a binary model like multiplication sort of says it's all in or all out. It's one or the other. It's true or it's false. Where suitability gives you a kind of a range or a ranking. So go ahead and try this on your own. Simply add the now water with the old trees, just like what we did up here. Take your old trees and add it to your old water raster. Just simple as a addition. So in our raster calculator up here, we'll just be saying now water. You find your tools up in your operators up here, plus old trees. And now water plus old trees. That's going to give you, well, I called mine suit stumps. So go ahead and call yours like suitable stumps. So think about this before you do this. You're going to end up now with how many values in your raster? So values of 0 and 1, or is it going to be 0, 1, and 2? Keep in mind, you have ones and you have a 1 in one raster, you have a 1 in another raster. If those two cells overlap in that same area, the output's going to be 2. So you could have a range from 0 to 2 with your, when you're adding rasters together, kind of a suitability approach. So I'm going to go ahead and pull up my suit stumps, what I called that. And there we have, well, here, I'm just going to attach a color to this quickly so you can kind of see the difference. So these are now 3 values we have from adding those rasters, where before we only had 2 down here, in our stumps too. So suitability stump sort of is telling you where the dark purple areas are, those are going to be most likely the areas that are going to contain a stump field, given the input data. So values of 0 pretty much meant don't even bother looking there, or, it's all clear for boating type of a thing. And values of 1, it's either water or it's trees, it's one or the other. So, if I move up the stumps, either one of these above, we should see that these dark areas in purple right here should meet exactly what either one of our prior stumps did too. So the values of 2 are the same as the values of 1 in our 2 other stump rasters that we created. So hopefully that makes sense. If not, let me know and we'll help you out with that. So good, we kind of ended up going through a couple of different approaches. Now you can also add weights to your suitability model. For instance, if you are adding your rasters. Adding your rasters is a great way to add suitability. Let's say you wanted to give a little bit of a weight to one of your rasters. In this case, I put 0.75 to water. Like I wanted to give water a little bit, 3/4 of a rank, as opposed to the old trees. So with that being said, I'm taking my raster, multiplying those values by 0.75, and I'm adding it to my old trees raster, multiplying that by 0.25. So when you think about what we're creating here, if you're looking at these decimal values here that we're creating, you should automatically be thinking floating point grid, because we're adding in decimal values to our output raster. So go ahead and type this in to your raster calculator and call it Stumps 2. So again, we're adding a weight, 0.75, 0.25. I mean, we could have it 0.25, 0.25, 0.25, 0.25 for if we had 4 rasters, each being given quarter of a percent. But in this case, there are only really 2. So go ahead and type that into your expression window and title that, what do we call it there? Stumps 2. Remember, we're creating a floating point layer here now. So I'm going to move that up and show you what that looks like. So here we have a range of 0 to 1, and that should make sense because when we added our inputs to our raster, we had now water, which contained values of 1 and 0, and we had old trees that contained values of 1 and 0. Right up here, we are old trees, the output was 1 and 0, now water was 1 and 0. So all we're doing is taking a percentage of that. And so if we have 0.75 and 0.25, we're adding them, multiplying it, and then adding them together, the max we can have is 1, because we have 100%. The lowest, of course, we can have is 0. So we'll have a range of values in that case. So if you were to click around in here, you'll see different decimal values. And if you click on the highly red areas, the darkest red, those are values of 1. And then in the lightmost areas should be 0 for us. So it's another way of making a suitability type of raster, like almost kind of a ranking raster, but you can add weights to it. That's what's kind of neat. So keep these little tips and tricks in the back of your mind as you're thinking about maybe a final class project as we get down the road to that. These are simple, they're easy to create, and they're tangible. They're definitely doable. Okay. So good work, everyone. You found the areas that were once trees that are now water in present day. Another activity that I'd like to step you through or encourage you to work on your own is thinking about the areas that were once marsh. So values of 2 in 1875. So, first off, pause the video, go back and explore your data for both of those rasters again. And we know that marsh in the 1875 raster, or that would be the L75 Calc 7-G. So values of 2 in L75. That are now something else other than marsh. So something else other than 2 in present day, or 1989. So the 2 data sets again that you'll need are the L75 and the L89. So you'll be able to do keep the current data sets in your session, and there are many ways to accomplish this. So I'd like for you to pause the recording right now. I'd like for you to think about what we just did, what we just went through with our Stumps demo, with our Stump project. Think about what would be some sample statements that you would perhaps write out. Could you write condition statements? Could you write if statements, or what are you thinking about for that? So pause the recording, get a couple pointers down, refer back to your operators in your spatial manual that you took a look at in one of the earlier videos, and see what you can come up with. And then when you're ready to compare notes, resume the video here and let's see how you did. All right. Whether or not you took a pause to think about that or whether you didn't, the choice is yours. But let's go ahead and explore this. Some sample ways we could do that. And I'll work through this with you in our pro session right here. So once again, I'm going to move up the two data sets that we need, which are L75 and L89. So we have those up and running. Again, we're clear, nothing is selected for us. And in the word solution guide, here's our second in-class activity. It's sort of kind of doing a Marsh analysis. You know, this is a great way. So if we're finding areas that were once Marsh, just like we looked at, this is the same thing that we're looking at here. Find areas that were once Marsh, or in this case, values of 2 in 1875, but are now something else other than Marsh in 1989 here. Generate the area for your calculation in meters. Our cell size is in meters. So we have our data provided here, as I mentioned, for that. So really a great way to think about this activity is if you're kind of thinking, what could I use this for? This is a great way to think about marshland that was lost. You know, there's always a lot of discussion about wetlands and their importance. This is a great way to assess the total area lost out of in this case, Marsh, you know, for the time period here from 1875 to 1989. So it's a great estimator to see how things have changed. So before we were looking to find areas of common overlap for stumps. In this case, we're looking to see how much, you know, how much marsh we lost. So this is a great way to think about that. So we'll work through these together, and some sample syntax that I'm breaking down, you know, you could put this together in all one big nested statement, like we did before in one of the other Stumps projects that we looked at. And so, you know, I didn't create this yet, but I can work through that with you. But instead, I'm going to work through one by one. But if you want to, you can try this condition statement that says in the L7, well, in 1875, that's what this raster is, the L75, Calc 7-G, where this is tested and evaluated for 2, which is Marsh, and we're in present day, our L89 raster is something else other than 2. That's what this operator means right here, or this different test. It's like an exclamation mark with an equal sign. And I think it's in here. I don't use it too often. Here it is, right here. So it's sort of not equal to is another way of thinking about that. Anything not equal to 2, where that is true, in other words, where these things are, where one is finding Marsh and the other one is something else other than Marsh, where that's true, write a 1, and where it's not, write a 0. So this is the all-in-one nested approach that will give you your output immediately. But I want to step you through breaking these down because I want to talk about this output and how we can merge side-by-side rasters together, because we're not going to be dealing with rasters that are really overlaying quite as much in this instance. I'm going to pull these data sets out so that they're side-by-side. And then how can we actually merge those together into one composite layer? That's the value of this exercise. Let's take a look at it. So right off the bat, I'm just going to copy this for the time being here. And then we'll talk about it. But in the first one here, I'm going to create a grid called 1, or a raster called 1. One of the grids is a condition where the L75 is tested and evaluated for Marsh, and where the L89 is tested and evaluated for all values less than Marsh. So like values of 1 is pretty much what this is going to do. So less than 2, value 1, where those areas are both common, we're going to write out as a value of 1. And where it's not, we're going to write a value of 0. Let's try it. We're going to call this one. I'm going to call this raster, I'm just going to name it 1. So all of our, check your parentheses, your order of operations here, everything should be okay. And then where it's less than 2, good. Okay, let's run it. All right, I'm going to turn off some of my other layers so they don't get in the way. Okay, so I have one, and it gave me just some areas right up here where those values were once marsh and are now basically water is what we were telling it. It's less than 2. So if it's less than 2, well, we know values of 1 were water from our other descriptions in exploring our data. But in this case, it just wrote it to a value of 1, not because it's water, but because the true parameter was that it's something else other than 2 or less than 2, to be more clear on that. Okay, so let's clear our window. Use my clear expression. We're going to create a new or another grid called 2. And this will be a product of, I'm just going to copy this as well, kind of talk through those. We're saying now, we're just doing the opposite. The first one, these are exactly the same. The only difference is I'm calling the second raster for values above 2. So other than marsh, I want it to be anything but marsh, but above 2 values of 2. So let's go ahead and run that. It's going to copy and paste that in here. And I encourage you to type that in there so you kind of get the idea of what to expect and how to see the parentheses and what to look for. Let's go ahead and run this. Okay. And we have 2 different layers going on here. What I'm going to do is just hollow out my values of 0 so that we can see everything. I'm just going to say no color. And then I'm going to do the same for my raster I just created for no color. There we go. Now I'm going to see these side by side. We'll try to give these a color that we can see easily enough. Dark, something dark, we can tell. Well, I guess we'll have to kind of zoom in on that here, but that maybe is a poor color choice. Let's go with something a little bit. Yeah, I don't know. Find a good color pattern that works for you, and there we go. At least we can see that a little bit better. So as you're panning around on your screen, find the areas here, and what we're seeing right now, in the last exercise, we multiplied them together. We multiplied the layers together because they were both 1s and 0. They shared some common overlap. But when we did the less than or equal to, we automatically created cells that were one or the other. Like they weren't overlaying anymore. So kind of when we use that relational, like the less than or equal to, we're automatically kind of subsetting data out in a new way. That's what it means. We're subsetting. We're sort of querying that data out in a new layer by itself. But as we're looking at here, if we zoom in on some of this, if you turn these on and off, nothing is overlaying. These cells are not stacked. They are side by side. And because we use that relational operator, again, it pulled out data, it queried it out and wrote it to a new layer, essentially for us in form of 1s and 0s, but there's data side by side. Always a question is, people think like, gosh, I have these 2 layers. They're side by side. There's no overlap on them. If you tried to multiply these together, you're going to end up with values of 0 for your output. It's going to be all 0 because there's just 0s and 0s all over. And there are some 1s, but the 1s don't overlay with other 1s. They overlay with 0s. That's why this would not work for multiplying it. But you can try it, see if it works for you, I guess. But I want to show you now what happens that we can add these 2 together. And when we add them, we're not going to be, since we have values of 1s and 0 here, being that all the colored areas we see, the purple and the black, they're side by side. So if we add them to 0, if we add these, we're still going to just end up with 1 and 0. That'll be our output together if we merge them. We're adding the cells. There's still overlap, I guess. Let me say that. There's still overlap, but the 1s are not going to overlap with each other. The 0s, there's too many 1s and 0s in here. The 1s are not overlapping. But to be clear, there is overlap, yes, but those values are 0. And that's why multiplying will not work. So let's go ahead and add one grid, this one, and add it to the value of the other. Just so you can kind of see what I'm talking about here. If I just added another color in here, you can see that the dark colors here, the black, are overlain by this color of green, which is a value of 0 for me. And that's why multiplying these will not work. But yeah, I shouldn't have maybe said that there's no overlay going on. It means that the values of 1 are not. In our case here, values of 1 are not overlaying. And that's why multiplying would not be a good choice for this approach. But we're talking about how can I merge these layers? How can I merge the two values of 1 that I have going on here? How can I merge them into a new layer? But we're going to do that by adding. So let's try it. What did we call this one? We called it output. So let's create a new grid called output. Output, we're going to add 1. Plus 2. Run. So we're still adding 1s and 0s. It's just that the 0s are going to be adding with 1s. So here, let me just kind of mute this out here. Mute out our 0 color again. And what I want to show you is that if you turn this on and off now, you'll see that we've sort of in effect, I'll call it kind of merged data. It's another way to integrate or to assimilate data that might be parsed out that you want to put together, that there's still some overlap between 1s and 0s or something like that going on, but or whatever values you have, but you kind of want to extract or pull together the values of 1 into a cohesive data layer. And that's what we end up with here. So it's kind of a good learning activity. All in all, to see, we add these together, we're going to have the right information. It's just a new way of thinking about that. Sort of merges those side by side. And you also could try that nested statement as well. But as you work through that, or as you work forward in that exercise, I believe the result that you should get for this would be approximately if we checked our output in either one of these, grid 1 plus grid 2, or if you did the con statement, you should end up with about 41 or 4,136 cells that met the criteria of Marsh lost. So if we explored our properties here, we can see what our cell size is. So we're dealing with a 5 by 5, it shouldn't be a surprise, but a 5 by 5 meter cell size. So, we have 5 times 5, which is 25 meters squared. Now you'd multiply that by your count. That would give you the total area of Marsh lost. So in a sense here, I come back over here just to show you this. You might end up with something that looks similar to this. So you might have on yours 25 meters squared times 4,136 gives us about 100 square meters of marsh that was lost in that time period between our two land cover dates. So in any event, that was an overview of finding the areas that were once marsh, that are something other than marsh. But in the end, practice with your data sets. We looked at two scenarios here, one of Stumps doing a basic change detection. We looked at another one that was a little bit different, where we're using some relational operators and then kind of using add to pull some of our values back together so that we could try it in a different way. So practice this and practice it as many times as you'd like. That's what the video is here for. But otherwise, if you have any questions, please feel free to reach out. And as always, have a good week, and we'll see you all soon.